Okay, so on top you put A, B, C. Then can you continue from here?
Okay.
I give you 5 minutes. When you're done, let me know. Dylan done?
Like,
Sorry?
no.
Okay. Where are you almost done?
Yeah, I think so.
Okay. A must times what?
Times minus 3/2x for x. No, you must make x minus 3/2.
No, this one. What's the bracket that you must multiply to A?
That's 1 square.
Okay. Don't need to unmute yourself, just me and you. Then B, what must we times?
X minus 1 and 2x plus 3.
Okay. And then the last one?
2x plus 3.
Very good. Okay. Then you can do it. Okay, come, quick. When you're done, send it to me, okay? Wow. Wait. Okay, good. Now, then when they ask you to integrate this one, remember last lesson I said there is no quotient rule or product rule for integration, right? So when you're asked to integrate something complicated, you make it simple. So integrating this is the same as integrating your partial fraction. So since I rewrite, okay. So since your A is 6 and 25, and then your B is 3 and 25, this is minus. And then your C is 14 and 5. Integrating this is the same as integrating this. So Dylan, can you tell me? When you have bracket to the power of -1, how do you integrate that? Don't care about the 6 over 25, just care about this.
Is it do you bring up the 2x plus 3 minus 1, like to the power of -1, then it will become a log.
Very good. It becomes ln. When you integrate power -1, it becomes ln. So 6 over 25 ln 2x plus 3. What am I missing now, Dylan? There's one more thing I need to do. When you integrate, you must divide. Divide by differentiate of the bracket, which is 2.
2.
Yes, one more time. This is also bracket power -1, right? So we change it to ln x minus 1 over nothing lah, because it's 1, so don't need. Okay, next one, 14. Okay, now this is bracket power -2. Can I change it to ln or not?
No, it becomes -1.
Yes, power increased by 1 over the new power times differentiate of the bracket. Very good. When there is no number on the integral sign, what must I do? After I integrate. Yes, plus C. Awesome. Okay, now we got it. 3 over 25 ln 2x plus 3 minus 3 over 25 ln x minus 1 plus, sorry, now become minus already. Minus 14 over 5 x plus 1. X minus 1, sorry. Okay, now Dylan, can I ask you? Okay, This one, right, when your answer is like that, we can actually simplify further. Okay, see here. This is 3 over 25. This is 3 over 25, right? If I take out 3 over 25, you have ln 2x plus 3 minus ln x minus 1. Now, what can you do about this when it's minus?
Over 2x plus
Yes,
3 over.
very good. Yes, so we write it like that. Okay, always write in simplest form. So ln 2x plus 3 over x minus 1. Then it looks nicer. In this case, your answer is way simpler. Okay, and you got it. Okay, done. Can I do the next one? Okay, let's go on to the next one. So, Dylan, every time when you have a complicated fraction, you will think that, okay, I must do partial fraction. But before you even do partial fraction, what must you do first?
Simplify it
You must find the degree first. So what's the degree of the top?
2,
What's the degree of the bottom?
3.
Yes. When the top is smaller than the bottom, you don't need to do long division. So this one, we don't need to do long division. Then what is the second step?
Is it partial fraction?
Before you can do partial fraction, you must factorize the denominator. Here we didn't factorize the denominator because it's factorized for you. But if it is not factorized for you, you must factorize completely first. So now we take out x squared. Okay, this one I taught you last lesson. If it's x squared, what is this? Is x squared quadratic or repeated?
I think it's repeated.
Yes, it's repeated.
A
over x plus
then
b over
square
plus c over.
2x plus 3.
Okay,
Wait,
now
but
your turn.
when you have to do long division, yeah, there's always like the 1 minus at the start, right?
So 1 minus at the start. No, doesn't mean it's always 1. Okay, you must do long division to see. So example, when we do long division. Okay, I didn't take the question 3. We need to do long division. I will use that as an example. Okay, you finish 2 first. Then later on, there might be a mover that comes to move my sofa, so that may be a bit of noise. So I will mute myself for like 5 minutes, okay? Hopefully it's not during lesson time. Can you do it?
Yeah.
Okay. Okay, Dylan, do a bit faster, okay?
Okay, I'm done.
You got the answer?
Yeah.
Okay, now one more time. So if you want to integrate that, okay, this is 4, this is 1, this is -3. Integrate this is the same as integrating this. Come, Dylan, help me how to integrate 4 over x.
For ln 4 ln x.
Very good. Next one.
Mm,
This is power -2. So how?
x minus 1
Over.
X.
Okay.
Minus 1. Wait, why is it -1?
Okay, so because x to the power of new power over the new power. Okay, x power increased by 1 over new power.
Oh yeah, okay.
Okay, next one. There's 3 on top. So it's 3 ln 2x plus 3. What am I missing?
3 over 2.
Over 2 plus c. Okay, awesome.
Yeah.
Got it. -1 over x minus 3 over 2 ln 2x plus 3 plus c. Okay, good. So just now you were asking me, okay, you write down this one first. Okay, just now you were asking me that when you should, okay, do your long division. So if you see the next part, right? Okay. Oops, too much. Okay.
Don't
What's
think
the power here?
I haven't finished writing it.
Oh, okay, okay.
Wait, am I the only person today?
Joshua couldn't make it. Reina and Faith couldn't make it. I left one more girl. I don't know. I think she overslept. But it's okay. Today only Dylan. Okay, yeah. It's oh shit. All right, Tasha is here. Okay. Tasha, you take out a worksheet, okay? Never mind, you're not the only one that forgot. I think there's 3 more who forgot. I recorded the lesson, so if anything you can look back. Okay, I'll send you the link later. Dylan, are you done with question 2?
Yeah.
All right, okay. So the next one, right? So every time when you see a complicated fraction, okay, you know that you need to do partial fraction. But before you can start doing partial fraction, you need to apply 2 rules. Number 1, you must check for the degree. So degree means the highest power of x. The degree here is 3. The degree here is 3. So as long as, right, the top is not smaller than the bottom, you need to do long division. Okay, as long as the top is not smaller than the bottom, you need to do long division. So the top one is inside the division. The bottom one is outside. Okay, make sure that it's expanded form before you do long division. So now you can do long division. Okay. So 2 minus.
Wait, why is it 2x cubed minus x?
2x cubed minus x squared. Okay, copy this. This is
Oh,
the divider. Okay, so then you have 4x squared minus 5. As long as the degree here is smaller than this, you can stop dividing already. There's no way you can divide some more. Okay, so just like how you can always take, see, if 7 divided by 2, okay, can I say that 7 over 2 is 3 plus 1 over 2? Same thing, right? So how I get this part is, a fraction is always quotient, your quotient, plus your divider, sorry, your remainder over your divider. So I do the same thing, okay? So your fraction is the same as quotient plus remainder over divided. Okay. Same thing, quotient, remainder, divided. So every time when you do polynomial, right, or you do partial fraction, as long as you forget the formula, you just use simple numbers to see how you can form an equation. You just apply the same thing. It works the same way. Okay, but this is not done yet. This is just long division. The next step, you need to do your partial fraction for this bracket. Okay, for this smaller fraction. So now when you look at the purple bracket, the top degree is smaller than the bottom. Now we can start doing our partial fraction. So Dylan, just now I said, before you do partial fraction, what's the second rule?
There's a
Something
second
that you need to do to the bottom.
You make it 2x square bracket x minus 1.
Okay, just x squared, right? So we need to factorize. Okay, so number one rule, check if you need to do long division. If you need, please do long division. The second rule, when you start doing partial fraction, the first thing you must do is to make sure that the denominator is factorized. So we take out x squared. Okay, then when you see a fraction like that, okay, to know how many,
what if the quotient is bigger?
what if the quotient is bigger?
Some very long number like 2x squared plus something.
As long as the degree on top is smaller than the degree below, you can do partial fraction already. Just care about the degree. Okay, if the degree on top is the same or bigger than the degree at the bottom, you need to do long division. Okay, if you do long division already, the degree on top is still bigger, that means you didn't do your long division properly. Okay, so the amount of bracket at the bottom is the number of fractions you will get when you do partial fraction. So x squared is your repeated root. Okay, so that means this means two fractions, one fraction. So you have 3 in total, a over x plus b over x squared plus c over 2x minus 1. Okay, x squared is repeated and not quadratic. Now that you have this, can you guys help me find for A, B, and C? Okay, I give you some time. I give you 5 minutes. You help me find A, B, and C.
Wait, what am I supposed to do now?
Partial fraction. Okay, time A, B, and C, Dylan, just like just now. When you're done, can take a picture and send me. Tasha's done already. Dylan, quick.
I didn't know. So.
Okay. Yeah. Okay, great. So, okay, Dylan, see here. So, it's okay. Later, I'll let you try again. So, now you see integrate 4x cubed plus 2x. Okay, I think I erased this. I got no space really. So, okay, you can rewrite. So, this whole thing, later you will find out that A is equals to 10, B is equal to 5, and C is equals to minus 16 over 2x minus 1. Therefore, okay, 4x cubed plus 2x squared minus 5 over 2x cubed minus x squared is equals to 2 plus this whole bracket here. You have simplified it and break it into three smaller fractions. So just change it. Okay, so this is the complete partial fraction. Then now they ask you to integrate this. It will be the same as integrating this. Okay, the easy part, the easy integration, right? They will ask you to do partial fraction and then ask you to integrate. If I want to make this question hard, I will not give you the first part. I will just ask you to integrate. So you must know that there is no quotient rule for integration. Okay, there's no way you can integrate a complicated fraction. So you need to do partial fraction to simplify it before you can integrate. Okay, so you just have to take note if you see a fraction like that, even if the question didn't ask you to do partial fraction, most probably the question will be 6 marks because it requires you to do partial fraction before you can proceed to integrating. So now we can integrate 2, we change to 2x. This is x to the power of minus 1. Whenever it's power minus 1, you change it to ln. Okay, because power increased by 1 becomes 0, then everything becomes 1. Okay, power 0, everything becomes 1. So there's no way we can do that. This is our special case, ln. Next one, okay, this is power minus 2. So this is not ln. So we must power increase by 1 over new power. Every time if there's a constant, you don't know what to do, you put outside the bracket. Okay, last one. This is bracket power minus 1, same thing. So it's 16 ln 2x minus 1 divide by differentiate of the bracket, which is 2, then plus c. All right. Okay. Now we did quite a few partial fraction. Did I give you some time to complete C? 3. Can I give you about, I give you some time until 12:50. Can you help me finish question 4? Okay, I will go through if you didn't get it right. Okay. So slowly, before you do partial fraction, remember your 3 rules. Number 1, check the degree. Okay, and do long division if you need. Number 2, factorize the denominator completely. And number 3, break them into smaller fractions and find for your unknown. Okay, always check the degree first and factorize the denominator. Dylan, do
Yeah.
Hmm.
Wait, after the
Mhm.
the partial fractions, are we also supposed to do part 2?
Yes.
Okay.
Are you done with part 1?
Yeah.
Nice. So fast. 4 more minutes, Dylan. Try. Okay. When they say that the gradient is this one, be careful. So dy over dx is equals to if you want to find the equation, which is y, you need to integrate dy dx. Okay, then integrating this, there's no way you can use quotient rule. You need to change it to your partial fraction, okay, the simpler form. All right, then you must start integrating. So later on, because there's no numbers on the integral sign, there's a plus c. To find the plus c, you must make use of your coordinate and make sure that whenever you form an equation, it is in exact form. Okay, cannot be in decimal unless really no choice. Then you leave it in decimal. If not, always in exact form.
Wait, I got C equals 4/3 radius. Like,
4/3.
yeah.
Okay, let's see. Okay, so now when we integrate this is minus 2 ln x. This one, Dylan, is 2 ln x plus 3. The next one is not ln anymore, so it's always, okay, 8 put outside, bracket, power increase by 1 over the new power. Then you put plus c, right? So before I sub in my coordinate, it's better if we can combine whatever we can. So if you guys see here, right, there's a 2, okay? It is like this minus this. So you can combine 2 put outside, ln, it will be this divide by this, okay, because of the minus sign. Minus means divide, okay? Minus 8 over x plus 3. Now that when it is in the simplest form, then I sub in. 2 ln 2 minus 8 over 6 plus c.
Wait, I thought you must divide it by 2 there. That minus 2 over x.
Minus,
Yeah, because it's 2x minus 18. So I thought you have to.
where is 2x minus 18?
Because the thing that you are showing is 2x minus 18. The minus 2 over x plus 2x over x plus 3.
We mean this
So,
part?
no, the part on top. I thought that's x minus 9, but then you're putting in 2x minus 18.
Oh, got it. Okay. Right. Okay. So this part here, okay, I forgot. Okay, very good. So this one is x minus 9, but the one that they asked me to express is 2x minus 18, right? So the difference between the two, you can take out the 2. Okay, you can take out 2 from the top. So it will look like that. So you have 2x minus 9 over x cubed plus 6x squared plus 9x. It is equals to minus 2 over x plus 2 over x plus 3 plus 8 over x plus 3 square. So now since you don't want the 2, everything divide by 2. So divide by 2, divide by 2, divide by 2, divide by 2. Okay, then I must do the same here already. Okay, I use another color. Okay, then I think I made some mistakes here like that. Okay, I'll redo this part. Okay, so it's just minus ln x plus ln x plus 3 plus 4 x plus 3 square, sorry, not square, my power minus 1 over minus 1 plus c. Okay, then this part wrong already. Ayo. Okay, then same thing, this is minus, you can combine. So this is ln x plus 3 over x minus 4 over x plus 3 plus c. So now you can sub in ln 2 equals to ln 2 minus 4 over 6. So c is equals to 2 over 3 lah. Okay, once you found c, you sub c back. So this is your equation right here. You found c, you sub c back, therefore y is equals to ln x plus 3 minus 4 over x plus 3 plus 2 over 3. That's it. Okay, so must be careful. Just now I'm not careful. I didn't see that they are different. Okay, so you must try to make them the same first. Then integrate this is the same as integrating this. All right. I'll give you some time to write down. When you're done writing down with 4, can you help me put a thumbs up? Okay, Tasha, you done? You start with 5 first, huh? Dylan, you done?
Yeah.
Okay. Now the next one, okay? So partial fraction one, as long as you know that if I give you a complicated fraction, okay, the hardest they can make a partial fraction integration question is they don't ask you to do partial fraction. So as long as you know complicated fraction, we must do partial fraction first, then you are safe. Okay, then you just have to make sure that you can partial fraction correctly and then integrate correctly. Okay, differentiate then integrate is the harder part because integration is very limited. Every time when they give me a integration question, they can only test me on simple integration. I can only reverse method 1 of differentiation or reverse method 2 of differentiation. But there's no quotient rule, there's no product rule. So most of the time, if I ask you to integrate something complicated like this one, okay, looks like quotient rule in differentiation, you must look at the clue that they give you. The clue is they will ask you to differentiate first. Okay, so this is your clue. So let's start in differentiating first. Dy over dx is copy the back, differentiate the front, plus copy the front, differentiate the back. Okay, then don't forget to factorize completely. Bracket power half, power minus half. Take out the smaller power. Okay, can you see that if you get the same as mine? Okay, so every time when they ask you to differentiate, then integrate. the differentiate part is your clue. So the first thing before you do anything, okay, no matter how confident you are, please help me write down. If you differentiate this equals to this, then you integrate this, you get back this. Always write down. So integrate minus 3x over is equals to the top. Always write down the clue. This is your clue, the reverse. Okay, always write down the reverse. This is your clue. Okay, so every time when I want to integrate something, I will start off with using my clue to help me. Okay, so if you see here, this is my clue. This is what they want me to integrate. Dylan, can you help me? Can you tell me what is the difference between my clue and what they want me to integrate?
Yes.
Compare this and this. What's the difference?
The bottom is smaller than the top.
No, this and this is the same. The denominator is the same, right? How about the...
Oh, this one is -3, so you multiply by -3.
Yes, okay. So the difference between this one and this one is that this has a -3. Okay, so I must remove it. To remove a number, you divide it away. So this one, okay, I put here by multiplication is because you can just times a certain number to get rid or to add a number that you want or you don't want. So you don't want the -3, you multiply by -1/3. Okay, the number that you don't want, you put below. If you want to add in the number, you put the number on top. So that's the key. Okay, minus you don't want, you times another minus. So whatever you do on the left side, you do the same on the right side. Okay, I can simplify now first. Cancel, 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 cancel. I left with integrate x over square root 1 plus 2x. Can you see that now it looks the same already? Okay, then the other side, there's no way I can simplify. The only way is to put the minus inside this bracket if you want to, okay, not compulsory. If you want to put as little negative as possible, you just put the minus into the bracket and you flip, okay? So as little negative as possible, reduce careless mistakes. So up to you if you want to do that. So the final part, okay, to make them really the same, there's numbers here, we add the numbers. Okay, when you add the number, you do the same to the right side, like that. Okay, then from here, it is easy already. Number sub in minus number at the bottom, you sub in. So when you sub in the number, just be very careful. Sometimes when I have a constant, right, I like to take it out of the fraction. Sorry, take it out of the bracket so that I don't have to put too many fractions inside, but up to you, okay? So I'll take out 1/3. I put in 4 in, 4 minus 3 is 3. Uh, 1 minus 2. Sorry, I copied wrongly. This is 1 plus 2x. Okay, so 8 plus 1, 9. Square root 9 is 3 again. Minus 1 minus 1 is 0. Okay, everything's 0 already. Don't need. So I got 9/3. Okay. If you can do simple calculation, just do it by yourself, because if you put too many things in the calculator, sometimes you make mistake. Okay, so every time when you see this sort of question, especially integration, you need to sub numbers in. It's best if you do 2 times, especially when the equation is long, so that sometimes 80% of the time, the 2 times, you will get a different answer. So you must do the 3rd time to double check. Okay, make sure that you get the full mark. If you're okay with question 5, no question, can you help me put a thumbs up once you're done copying? Okay. Dylan, you okay?
No.
Which part?
Still copying.
Oh, okay. When you guys are done, I give you some time to do question 6. Okay. Once I'm done with 6, I will give you a short break. Then I come back and continue with the harder questions. Yeah. So can you help me to do question 6 and send it to me by 1:15? Okay, I give you some time. Slowly do, slowly start. Don't rush.
Yeah,
If
what
you
is
learn
this?
any questions, let me know. Where?
What are we doing
Sorry, I
now?
can't hear you.
Wait,
Do
what is
question 6. Do question 6
what is
after you're done with 5. Sorry?
like which chapter is this?
You mean which chapter is this? Is this worksheet?
Yeah.
Integration lah, integration technique.
What kind of integration is this? Is it partial fractions?
No, this is differentiate, then you need to integrate. So every time when I give you part 1 of the question, you differentiate. Part 2, I ask you to integrate. That means you must use part 1 as
The clue.
the clue. Yes.
Oh.
Okay. Yeah. Okay. Good, Tasha. You go for a break first. Come back by 1:20. Okay. Hey, Dylan, when you're done, send me.
Wait, part one of the whole thing.
The whole thing lah, of course. Mm.
Okay, I got it.
Send me first.
Okay.
Good, Dylan. Okay, go for a break first, yeah. All right, both of you back. All right, okay. Dylan, back. I can't hear you. Dylan. I think your mic is not working. Okay, come on, let's see here first. Okay, so same thing. Question 6 done. Question 7. Okay, I mix a bit off. Now they mix a bit of rate of change together with integration. Okay, can I let you guys try? Okay, Dylan, try question 7. Finish it. Same thing, finish, Sammy can.
Wait, what do you say?
Do question 7. Same thing, differentiate. And then try to do part 2 and part 3. Okay, I will do question 8 when you are done.
Are we only supposed to do part 2 and part 3?
Yes. Oh,
So we rather do part 1.
need lah. You need to do part 1 to do part 2 and part 3, Dylan. How to do part
Now
how
I
to
knew
do
how-
part 2 and 3 without part 1? Because the 2 is harder. I'm pretty sure part 1 you don't need my help, but I'm not sure part 2 and 3. Can you try? You remember how to do dy dx? I mean, do you remember how to do rate of change? Right? Okay. As long as you can do, your rate of change equation. No problem doing part 2. All right. Dylan, can you do part 1?
Yeah.
Okay, good. Tasha confirm can do part 1, so I'll just keep that. Okay. Then for part 2, okay, you want to find the rate of change of x. And then they give you that y is increasing at this rate. So every time when you see rate of change, you look at the equation given to you. The equation given to you is here. So based on this equation, you form the rate of change equation. So it's always rate of change of subject, dy over dt, is equals to the differentiate of this, which is dy over dx, times dx over dt, times the rate of change of the variable here. Okay, so whatever variable is on the right side remains on the right side. Whatever variable is on the left side, whatever variable is on the left side remains on the left side. Whatever is on the right side remains on the right side. Okay, don't swap them. So they say that y is increasing at the rate of 3. This is 3. Then dy over dx you have already. Okay, you want to find for the rate of change of x. This is dx over dt. And they're very nice. They give you x equals to 2.5. So you just write here x equals to 2.5 and sub this value in. Okay, can I ask Dylan, if I give you, instead of x, I give you y, what should you do? I give you y, but you need x. So what should you do?
You say dx over dt is that thing divided by.
No.
Wait, but they gave you
Harsha,
x.
what should I
They
do?
give x. They give x. They give x.
No, what if they give y? What if they give you y, but you need x? How?
You sub into equation.
Yes, very good. Okay, so if I give you y, you sub into here to find for x. Okay, Dylan?
Wait, but how do you find it
Be
from the
careful,
top?
So you let y be 3, and then you just cross multiply. Obviously, they will give you a value that you can solve. Okay, this one is a bit unsolvable like that. So just be careful. If they give you a value that is not what you want, you must search for that value indirectly. Okay, so okay, I erase this. This is not okay. So now that you can sub x inside, okay, this question quite nice to you. Let me just have it 12 times 2.5. 13. Oh, there's a cube here. Mhm. Okay, then you got units per second. Dylan, you get that?
Yeah.
Okay. Can you do part 3? Okay, so just now they asked you to differentiate. Now they ask you to integrate. Before you can do integrate, what must you write down? You must write your clue, right? So you differentiate this equals to this. Then now you integrate this, you get back this. So Dylan, the number that they want is 20, mine is 12. How? The number that you don't want, you multiply, but you put at the bottom. The number that you want, which
Yeah.
is 20, you put on top, right? So you do the same to the left-hand side, the right-hand side. Okay, 20 over 12. Okay, 20 over 12 can be simplified as this one gone. So you left 20. Here, this one divide by 4. So 5 over 3. Okay, not done yet. There is number on the integral sign 6.5 and 0.5. Here you also put 6.5 and 0.5. Can you see that you can factorize 3 from here? Okay, I will do that so I can cancel away. 2x minus 1. Okay, easier like that. Then you sub in your values. You get your answer. Dylan, when you're done, can you help me take a picture and send me? All right. Dylan got the answer?
Yeah.
Okay. Now we see the next one. Okay. So the next one, partial fraction again, you check. Okay, power 1, this is power 3. Don't need to do long division. Straight away, we can go on to doing partial fraction. So when you do partial fraction, 2 brackets means 2 fractions. So a over 2x plus 1 Dylan, am I correct like that?
No.
Which part? Which part?
It's only bx plus c.
Very good. Okay, so you have okay, the trick here, right, is that every time you see bx plus c, we always use coefficient instead. So if you see, right, if I want the code by comparing the coefficient of x squared, on the left side, there is no x squared, so the coefficient is 0. But on the right side, it is a plus 2b. So we can say that a is equals to minus 2b. Okay, this is equation 1. Then, now we can find for a by letting x be equals to half. So let x equals to half. Okay, then you can find. Okay, did I do something wrong again? X equals to, sorry, not half, minus half. Okay, we get a equals to minus 2. Okay, once we found a, we can find for b minus 2 equals to minus 2b. b is equals to 1. Okay, once we found a and we found b, we can let x equals to 0. And find for c. So we found a, b, and c. Okay, so whenever you see bx plus c, it's good that you use coefficient. The steps will be shorter. Dylan, once you're done copying this, can you let me know? Mm-hmm. Dylan, still not done?
Yes, I'm done. I mean,
Okay, so now they ask you to differentiate ln for part 2. Differentiate ln x squared plus 3 over dx. So differentiate of ln is 1 over the bracket times differentiate of the bracket. So 2x over x squared plus 3. So once you have that, okay, we can go on to integrating. So whenever you see differentiate, then integrate, you must write down the clue first. So since you differentiate this equals to this, you integrate this, you will get back that. So always write down the clue first. Integrate equals to ln. Okay, this is for part 3. You differentiate this, is this, you integrate this, you get back this, write down. Okay, then we copy down what they want me to integrate. They want me to integrate this. This is too big. I can split it to my partial fraction from just now, right? So I copy my partial fraction. So when you do partial fraction, your A is -2. And your B is 1. Okay, integrate this is the same as integrating this. Now we integrate one by one. How to integrate this one, Joshua?
Wait, I want to integrate which one? This one.
This one, the first one. Yeah.
Need to get the clue from part 1, right?
Don't need now, this is just a constant. So how? This is bracket power -1.
-2 ln 2x plus 1 over 2.
Yes, -2 ln 2x plus 1 over the differentiate of the bracket. Now the next one, okay? This is x over x. This one you can't integrate, you must make use of your clue. So Dylan, if you see this is x, this is 2x, what must you do?
Divide.
No, times what?
I mean times half.
Yes, okay. So the number that you don't want, you put at the bottom of the fraction. So times half on the left, you times half on the right. Cancel, you will get this. So integrate x over x squared plus 3 is equals to this. You just copy it down. Okay, then actually there is numbers on the integral sign I never put in. So now I'm going to put it in. When you put in, you open bracket, you sub your numbers. Okay, so cancel the 2 before you sub numbers in. Now you can start putting the numbers in. Minus ln 3 plus half ln 4 minus ln 1 plus half ln 3. Okay, so this one we cancel. Ln 1 is 0. 4 is 2 square, power can bring down, so it becomes ln 2 minus 3 over 2 ln 3. Okay, they never say that they want exact form. You can leave it like that or leave it 3SF. Both you will get it right. Okay. When you're done, can you help me put a thumbs up? Okay, Joshua, okay with this? This is the part that you're not sure, right?
Wait, Joshua. Oh, there's another boy now.
You act like you don't know him. Dylan, done already not? Dylan, move on. Okay. Dylan, done?
Yeah.
Okay, next one, yeah. So when the question say that I want you to leave it in this form, you know that you have to do long division. Joshua, do you finish 9A?
Yeah, the whole question.
Finish already, huh? Very good. Okay. So Dylan, can you try part A and part B? Okay. Tasha and Dylan, when you're done with part A and part B, can you send it to me? Okay. Joshua, I send you another practice. Okay, you can try that if while waiting for me to go through. Okay.
Yeah, my 9C might not be very correct.
Okay. Tasha, I also send you in case you do too fast. You got extra questions to try. Okay. Very good. All right. Dylan, come quick. Dylan, your favorite beanbag is gone.
Why?
I gave it away. Gone. Okay. So while you do, I help you as well. Okay. If you can do it by yourself, then do it by yourself. So the top one is inside, the bottom one is outside. So we always have quotient. Equals to quotient plus remainder over divided. Okay. The next one, part B, they ask you to differentiate. Remember, when you differentiate, it will be copy the back. This is your product rule. Copy the back, differentiate the front, plus copy the front, differentiate the back. Okay, so you have 2 over ln 2x minus 1. And you get this. Okay, so for part C, they ask you to differentiate, then they ask you to integrate. Before you even copy what you need to integrate, you copy your clue first. So differentiate this equals to this, copy. Okay, and then 1 by 1. So they asked me, right? They only want the ln 2x minus 1. Okay, this time round, we need to do splitting. So can you guys see that I only want, right? I only want this part. Okay, I only want the, why is mine so weird? Sorry, I think I copied here wrongly. 2 ln 2x minus 1 plus 4x over 2x minus 1. Okay, copy wrongly. 2 ln 2x minus 1 plus 4x for 2x minus 1. Okay, sorry, we restart. Okay, I only want this part. So since I only want this part, right? First thing what I do is I split it up. Okay. So this is my clue. Integrate this is equals to this. I only want this side, I split it up. Okay. Once you split it up, you let what you want to be the subject. So this is plus, bring over, minus. 1 by 1. The 2 I put outside. Okay, so can you see? Plus, I bring over, minus, the integral sign stays. Okay, then now, from your clue, we made what you want the subject, but not really yet, okay? You see here, there is no 2, but there is 2 on your side, You don't want the 2, everything divide by 2 first. So divide by 2, divide by 2, divide by 2. Okay, then all we need to do now is to integrate this one and we can get it. But I can't integrate this one still. Okay, x over x, I can't change it. So what I do is, I've made use of my part B clue, but I still have my part A. So let's look at part A. Part A tells you that 4x over 2x minus 1 can be split into this, but you don't want 4x. You wanted 2x. So Dylan, what must I do? I don't want 4. I want
Times
2.
half.
Everything divide by, everything times half. Okay, everything divide by 2 or times half. So I know that 2x over 2x minus 1 is equals to this. I will swap this away to become this one. Okay, I swap these two. So we are almost there. Integrate of 1 is x. Open the bracket, the minus belongs to all of them, yeah? Plus, okay, this is 1 over bracket. So this bracket power minus 1, we change it to ln. Okay, expand the bracket, you will get the answer. That's it. Okay. Any question? Okay, Joshua, do you get it right? All right. Okay, give you all some time to write down. And then question 10 is very similar to question 9, just that the numbers a bit different. Okay, so just to recap, every time when you do part C and you see differentiate and integrate, definitely part A and part B are your clue. You need to make use of your clue in order to help you do part C. Okay, so write down the most obvious clue first, the reverse, which is this one. Okay, write down your reverse first. Okay, then you can manipulate. So the hardest integration question will require you to split, like what I did here. Okay, plus bring over minus. Okay. When you're done with this, can you help me put a thumbs up? Nobody done. Only Tasha. Okay.
Me.
Joshua, you done already?
Wait, I don't have 10
okay.
now.
Okay, doing 10. Joshua, can you do 10?
I'm doing it now.
Okay, finish by 2 p.m. Okay, guys? Then send it to me. Okay, I think today we got some time for some practice, hopefully. I'm still here. Any question can ask me, okay? I'm gonna 是 Everyone okay? Can do? Part 1 and part 2? Wow, Trisha done. Wow. Okay. Okay, never mind. You send me still. I see. Oh, okay, wait, I saw it already. Joshua, well done. Okay, can do 11. Very good. Okay, Tasha and Dylan, okay, ah? Dylan can do or not? Part 1 and part 2. I can't hear you. Okay, 3 more minutes. Okay, Joshua, when you're done, you do the next one. Guys, as you do, I'll leave part 1, okay? Dylan can do part 1, right?
Zoop.
Okay, I will just leave this out. Straightforward. Okay. Next one, differentiate. You differentiate ln x squared plus 4. It's 1 over the bracket times differentiate of the bracket. So it's 2x over x squared plus 4. Okay, this one also quite straightforward. When I ask you to integrate, but before that is differentiate, you just have to write the clue first. So you differentiate this is this, you integrate this, you get back this. So integrate 2x over x squared plus 4 is equals to ln x squared plus 4. Okay, look at the one that they ask you to integrate. It looks very similar to your part 1. So we can just work from the part 1. Okay, so this is my part 1 answer. I will just bring it down. I don't want 2x plus 16. I want x plus 8. I have to divide by 2. So everything divide by 2. X plus 8 over x squared plus 4. 2x minus 1 is equals to minus x over x squared plus 4 plus 2 over 2x minus 1. Everything divide by 2. Then I have it here. Okay, so integrate. This is the same as integrating this. One by one we do. Okay. So, all right, this one. So I have here minus x over x squared plus 4. But, okay, I can't integrate this. I must look at my clue, which is here. Dylan, comparing my clue and what they want you to integrate, what must I multiply here?
Times minus half.
Yes, times minus half. So here also times minus half. So integrate. This is equals to this. I just swap. How about this? How to integrate this one? This is bracket power minus 1. And there's a constant on top. So this becomes 2 ln 2x minus 1 over 2. Is there numbers on the integral sign? No. So remember to put plus c. And that is your answer. Okay, well done, Tasha. Good. Okay. Okay. Dylan, you okay? When you're
No.
done, you let me know. No, okay? Okay. When you're done, let me know. Boom. Guys, if you can hear like uncles laughing, please let me know, okay? so noisy outside. I can't count properly. Okay.
Yeah.
Done. Okay. Now this one, okay, I'll do this one first. I will do 11 and 12. I will let you do 13. Okay. So everybody see here, yeah? Joshua, can you do 11?
But you cannot.
Okay. The key is you need to bring the power down. Every time when they ask you to differentiate ln, the key is to bring the power down. The power can be half if it's square root. The power can be a cube. Anything as long as there's a power you bring down. And this is your product rule, method 3. X term times X term. So copy the back, differentiate the front, plus copy the front, differentiate the back. You will have ln X plus 1. Okay. The next part, they ask you to integrate. So before you integrate, you must write your clue down first. Always write your clue down. You integrate this, give you this. Okay, so integrate ln X plus 1 gives you X ln X. Okay, this is your clue. If you scared that you missed out your clue, you can draw a box. Okay. Okay, then the next part, they ask you to integrate this whole thing. So you just copy. Okay, guys, can you tell me, can I integrate X? Can, right? X squared over 2, power increased by 1 over new power. But can I integrate ln? Is there a formula to integrate ln? No, right? There's no way we can integrate ln. So what we do is, we must make use of our clue. Okay, but our clue consists of ln X and 1. So we need to split it out. I only want this part, which is here. I only want this part. So from my clue, okay, from your clue here, I write down. So integrate ln X dx plus integrate 1 dx is equals to X ln X. I only want integrate ln X. So this part here that I don't want, I bring over. So integrate ln X dx is X ln X minus integrate of 1. So X ln X minus X plus C. Okay, so now you have it. Integrate of ln X is here. Now we can do this. Okay, so integrate of X is X squared over 2. Integrate of ln X is right here. We just copy. That's it. That's your answer. Sorry. Okay, when you are done, can I let you try 12? I just realized 12 is actually very simple. Okay, I give you until 2:15 to finish 12. Okay. Okay, Tasha, well done. You can do the next one first, yeah?
Wait, we're supposed to do question 12.
Yes, Dylan, for the past 5 minutes, you're supposed to do question 12. Quick. Okay, Dylan and Joshua. Sorry, Dylan only. Joshua sent me already. Dylan can send me your work.
No.
Okay, quick ah. Okay, so I help you a bit. So if you want to differentiate this. Okay, this is your product rule because you have x term times x term. So copy the back, differentiate the front, plus copy the front, differentiate the back, differentiate of exponential is copy the whole thing times differentiate of the power. Okay, then they ask you to evaluate this, but before that, since you have your clue, you write down your clue first, integrate this. Gives you the back, okay? Differentiate this, give you this. So we write down first. Now, Dylan, can you tell me which one do you want? You want this one or this one? If they ask you to integrate 3x to the power of 2x. A
3x.
or B?
It is A.
A or B? This is x e to x.
Oh, then
X
B.
e to x. Yes, very good. It's here. So since you only want this one, you need to split, and then this one you bring over. So we bring over. Okay, Joshua, can you help me see here? You got it right? But your presentation is a bit off. Okay, so exam you may make careless mistake if you do that. Okay, so you should bring over first, then you integrate. I think Tasha also did the same thing. Okay, you should bring over first, then you start to integrate. So just to make sure that your teacher understand what you're doing. Okay, copy the whole thing, divide by differentiate of the power. Okay, then only now you multiply by the number that you want. So this is 3, yours is 10. So you don't want the 10 at the bottom, but you want 3. So times 3. Okay, so you times 3 over 10. Whatever you do on the left, you do the same on the right. So I bring over a bit. Okay, we do the same on the right. Is there numbers on the integral? Yes, 1, 0. You add 1, 0 here. Okay, so then you can finish your work. Sub 1 minus sub 0. Dylan, then you will get your answer. Okay. Question 13 is actually quite hard. I finished 13, I give you a break first. Okay. Dylan, when you're done with 12, can you let me know? Put a thumbs up. Okay. Dylan, you got the answer?
Yes.
Okay. Next one. Tasha and Joshua, any of you got the answer for this one? Okay, let's see. Let's see if you're almost there. Okay. So this one, you must be very careful. The power don't belong to X. You cannot bring the power down. Okay, you can only bring the power down if the power belongs to X. Okay, one more thing you have to be careful. If you have something like that, ln yx squared, the power only belong to X. You cannot bring down. Okay, it must belong to X and Y. Then you can bring down the power. So doesn't mean that there's a power means you can bring down. Okay, so this power belongs to the whole thing. You cannot bring down the power. So this is your method 2, bracket power. So when you differentiate that, okay, power bring down, copy the bracket power bring down by 1 times differentiate of the bracket, which is 1 over X. So you get 2 over X ln X. Okay, this is differentiate. They ask you to integrate. So before you even integrate, remember what must we do? We write the reverse, which is our clue. Okay, then we copy what they want me to integrate. So they want me to integrate 3x cubed minus 5 ln x over x. Okay, for this, right, there is no quotient rule. You need to split it up first. Okay, you can't do partial fraction for this because of the ln. There's no way you can do partial fraction. So you split it up. How to split? 3x cubed over x minus 5 ln x over x dx. Okay, then you will have 3x squared minus 5 over x ln x. Okay, I just write it like that. So we know that we can integrate this, but we cannot integrate this. So once you know that you can't integrate something, what do? You look at your clue. Okay, you look at your clue. All right, So now you look at your clue, this one and this one. Joshua, what must you do? Here and here. What's the difference?
5/2 is it?
Yes, 5 and 2. So you don't want the 2, but you want 5. Dylan, what must you multiply?
One.
You don't want the 2.
Two.
So the 2 at the bottom, right?
Multiply by 2.
No, you don't
Oh,
want the
multiply
2.
by 5/2. Multiply by 5/2.
Yes. Okay. The number that you want is on top. The number that you want to get rid is below. So whatever you do to the left, you do to the right. Okay. So now you have it. Now when you cancel this, you have 5 over x ln x. And then you get this. So one by one we do. It's 3x cubed over 3 minus this whole thing. 5 over 2 ln x square. Okay. They asked me to find this first. So you must put plus c. Okay. Then they say hence show this one. So only when you finish integrating, then you can put the numbers in. Okay. If you straight away put the numbers in, you won't get this mark, the -1 mark. Okay. Must present properly. So all the difference now is that there is a number on the integral sign. So we just have to copy this, but the C you change to bracket. Okay, so, oh wait, I forgot to simplify this and the 3 can cancel away, okay? So you have x cubed minus 5 over 2 ln x square. The C change away to E and 1. Okay, so sub in E cubed minus 5 over 2. Ln E is 1, don't care. Okay, minus, you sub in 1. Ln 1 is 0, so this whole thing gone. Okay, so we have E cubed minus 7 over 2. They say show, remember to put shown. This is for part 2. Okay, all the way part 2, part 2. Mm-hmm.
Wait, Josh, so why do you take away the C?
Okay, because you see just now there is no number on the integral sign, right? Now there is. So when there's number on the integral sign, C you remove, you change it to bracket and number. Okay, so that's the difference when there is number on the integral sign and when there isn't. Okay, so when there's number on the integral sign, it's bracket number. When there is no number on the integral sign, it is plus C. Everybody okay with this part? When you're done, can you help me put a thumbs up? Okay, Dylan, okay?
Yes.
Any part that don't understand? All okay? Tasha, okay? Great. Okay, I'll give you a small break. Come back by 2:31. We will complete the next 3 questions if we got time. I give you a small quiz, okay? When you're back, can you help me put a thumbs up? Mhm. Good. Dylan, you back? Okay. Joshua, question 14 onwards, do you get it right?
Ah,
14 onwards, you get it right? All correct. 14, 15, 16.
16 blanked. Oh,
14 and 15 you send me, okay? I think 14 you send me already. Send me 15.
you
Okay,
show
Tasha,
14.
let's start first. Show me 14 already. Okay, so now let's start. So sine 2x plus 2x, Dylan back. Differentiate of sine is cosine. Every time when you differentiate, it's times. So times differentiate of the power of the angle. Every time when you integrate, is divide. So differentiate of 2x is 2. You get 2 cosine 2x plus 2. Okay, so if you see cosine square x, this is x, this is 2x, we must swap, right? So we swap, it becomes 2 cosine square x minus 1 plus 2. So you're left with 4 cosine square x, and that's done. Okay, so one by one, after they ask me to differentiate, the next part is integrating. So I know that I have to write down my clue. So integrate for cosine square x dx is equals to sine 2x plus 2x. This is my clue. I box it up. Okay, let's see who still remember. If, let's say, I don't give you the clue, oops, erase too much, okay? If let's say I don't give you the clue, but I'll just ask you, okay, how can I integrate cosine square x? There's no clue, there's no clue given to you. How can I integrate cosine square x without the clue? Anyone? Dylan, can you remember I told you last lesson
What did you tell me last lesson?
how to integrate cosine square without the clue?
Oh, you make it double angle.
Very good. Okay. Whenever I ask you to integrate cosine square or sine square without any clue, you use double angle to convert. Okay. So example, I ask you to integrate cosine square 2x. Okay. Your double angle says cosine 2a is 2 cosine square a minus 1. In this case, a is 2x. So if a is 2x, 2a becomes 4x. The only thing that you can change in a double angle formula is the angle. Everything else remains the same. So we make cosine square 2x the subject. It will be minus bring over plus cosine 4a plus 1 over 2. So integrate this is as good as integrating this. Okay, same thing for sine square. If it's sine square, I want to integrate this. I can use our double angle formula. Cosine 2x is 1 minus 2 sine square x. So sine square x is the subject. Minus bring over plus, plus bring over minus. 1 minus cosine 2x over 2. Integrate this is integrating this. Okay, so if there is no clue given to you, you still can integrate cosine square and sine square by using your double angle formula. Okay, never do this, never do this. Sine x whole thing square, and then you do your method 2, power increase by 1 over new power. Cannot. Okay, cannot. So you can only do this, power increase by 1 over new power.
Wait, well, what if they put sine x, cosine x? Like
Integrate of sine x, cosine x. Okay, very good question. If I ask you to integrate sine x, cosine x, multiply, right, Dylan? Multiply, right? So you know that 2 sine 2x, sorry, sine 2x. Okay, sine 2x is 2 sine x cosine x. So sine x cosine x is half sine 2x. You integrate this is integrating this. Okay, you still can use double angle formula, but in this case, you use sine double angle formula. Okay, so the reason why, okay, we can't use, so remember last lesson I say, okay, when I taught you differentiation, I say that if I ask you to differentiate sine cube x, what you can do is you can take out the power, and then you do this power bring down, copy the bracket power bring down by 1 times differentiate of the bracket. I told you that you can do this, right? Method 2. Okay, but why we cannot reverse method 2 for integration is because, okay, if I ask you to integrate a bracket with a power, you can do this power increase by 1 over the new power. You can only do it when x term, okay, is just x to the power of 1. If this is x squared, if the x term is x cubed, you cannot do this power increase by 1 over new power. Okay, as long as, okay, let's say this is x squared. So power increase by 1 over new power times differentiate of the bracket. As long as you divide by an x term, right, it means that you're integrating wrongly. I say again, as long as when you divide by differentiate of the bracket, and the term that you divide is an x term and not a constant, you're integrating wrongly. So you can't do that. Okay, so I cannot integrate sine square and cosine square by just putting the power outside like that. Okay, then if I really do that, I will get sine x to the power of 3 over 3 cosine x. See, I'm dividing by an x term. Okay, means this is wrong. So we can't do this. Exam, please be careful, okay? This cosine square, sine square question came out, I think last year or 2 years ago. I can't remember which year, but it came out. Okay, recently they start testing. So can you just help me put a star to this? This is important. Okay. So I went through cosine square and sine square. How about integrating tangent square? I can't use cosine double angle formula or sine double angle formula to integrate tangent square, right? So how if I got tangent square? Dylan? If it's
Yeah.
tangent square, how?
Oh, you make it secant square minus 1.
Yes. Okay. So you know that secant square is tangent square plus 1. So tangent square, okay, I brought down here. This is a formula given to you. You can make tangent square the subject. Why? Because we can integrate secant square. Integrate secant square is tangent. Okay, so just to sum up, if I ask you to integrate cosine square or sine square, you use double angle formula and you just make them the subject. If I ask you to integrate tangent square, you change it using this formula, make tangent square the subject. Okay, this one must know. So I'll erase this. Okay, we can continue. So this question is very nice to you because, right, instead of asking you to integrate cosine square, they actually gave you a clue. Not that bad. Okay, so we just have to apply the clue in this case. Pi, 2 pi over 3 secant square x minus 4 cosine square x. Integrate of secant square is tangent. Integrate of 4 cosine square x is this one. You just copy will do. Okay. Don't forget to put a bracket. Remember, calculator must be in radian mode. So can we all try together? Before I submit, right, I always like to simplify first. Then you submit so that you don't make careless mistake. So one by one, tangent pi is 0. Sine 2 pi is 0. Okay, tangent 2 pi over 3 is minus square root 3. Sine 4 pi over 3 is negative square root 3 over 2 minus 4 pi over 3. Okay, how I know all this? You just remember when your key calculator is 0.866 is square root 3 over 2, is 1.732 is square root 3. So you just have to remember the numbers, right? There's only 4 numbers to remember. Okay, you can write it down. If it's square root 3 over 2 that you see, sorry, if it's 0.866 something that you see, that's definitely square root 3 over 2. If you see 0.707, that's definitely square root 2 over 2. If you see 1.732 something, that is square root 3. 0.577 something is 1 over square root 3. You only have these 4 sets number to remember. Okay, it's always either of these 4. Okay, so as long as you can remember the number, because sometimes when a teacher tells you, okay, when you got a number, you just square it. Then you can form this. But in the exam, you're not that sharp. You won't know which one to square, which one not to square. If every number that you have, you go and square, you waste a lot of time. Okay, so it's just good that you recognize this 4 so that you know that you can sort to your cert form. Okay, so just slowly, we change it. Minus 2 pi plus square root 3 minus square root 3 over 2 plus 4 pi over 3. Okay, then we have minus 2 over 3 pi minus square root 3 over plus square root 3 over 2. So we can split it. Okay, I found my A term. My A term is minus 2 over 3 and my B term is half. Okay, so You can write this in your A Math booklet. Okay, just help me familiarize. There's only 4 numbers to remember, and you see it very often. When you're done, can you help me put a thumbs up?
Yeah.
Okay. Thank you. Okay. Last one. Okay, last 2. So let's see here. Slowly, they ask you to differentiate this one more time. This is product rule. Okay. So slowly do. Copy the back, differentiate the front, plus copy the front, differentiate the back. Differentiate of sine is cosine. Don't forget to multiply by differentiate of the angle. You get 2 sine 3x plus 6x cosine 3x. They ask you to show. Shown. Okay, so differentiate, then integrate. Okay, you guys know this by now. You can write your reverse. Integrate this, give you this. So integrate 2 sine 3x plus 6x cosine 3x is equals to 2x sine 3x. This is my clue. I play with my clue. Okay, so now look at what they want you to integrate this one. Look at your clue and look at the one that they ask you to integrate. Okay, there's 2 terms here, A and B. Dylan, which one do you want? This is closest to A or B?
Which one?
The one that they ask you to integrate
Oh,
is
B is
closer
close.
to A or B. B, right? So I make this the subject, but before I can make this the subject, I need to split. Okay, split it up first. Plus bring over minus. So integrate 6x cosine 3x minus integrate 2 sine 3x. Okay, then now you compare this one and this one. This is a 6, but the one that they ask you to integrate is a 2. So to make 6 into 2, you times 1/3, right? So we times 1/3 on the left side, we times 1/3 on the right side. Okay, simplify again. One-third always leave outside, okay, doesn't matter. Integrate of sine is minus cosine. Divide by 3. Okay, then there is a number, right? So you put plus C first. Then they say after integrate, then hence. So now we add in the number on the integral sign. Okay, then slowly we can get the answer. So sub 1 by 1. You sub pi over 2. 2 times pi over 2 is pi. Sine 3 pi over 2 plus 2/3 cosine 3 pi over 2 minus 0 plus 2 over 3 cosine 0. Now the key here is you only put this in the calculator. Don't put the pi in, okay? If not, you can never guess what the number is. Only put the 3 go in the calculator, this and this, especially when you want to leave it in exact form. So sine 3 pi over 2 is minus 1. So you get minus pi. Never put the constant inside as well. Don't put the coefficient inside. Just put the 3 go inside. One more time, you get 2/3 cosine 3 pi over 2 your calculator give you 0. So this is just 0. Cosine 0 is 1. So answer. Okay. So make sure when you sub value, only sub the trigo inside. So you can guess the third form. How to guess the third form? From here. Okay. When you're done, can you help me put a thumbs up? Joshua done? Dylan? Dylan.
Yes.
Okay. The last one is actually a trick question. Okay, so they say that integrate this, give you this, and then you don't know what to do really because you can't integrate fx without knowing what is fx, right? But if integrate this, give you this, can I say that I differentiate this, I will get back this? I say one more time. Since integrating this, you get this, we can reverse, you differentiate this, you get back this. So all you need to do is just differentiate the right hand side. Okay, don't worry about the C because you can never integrate a constant. You can never differentiate a constant, right? So this is product rule. Copy the back, differentiate the front, plus copy the front, differentiate the back. Differentiate of sine is cosine 3x times 3. Trigo always put right at the back. Okay, so you know that differentiate of this give you this. They factorize out e to the power of 4x. You do the same. That is your answer. Okay, so fx, they want fx. Fx is equals to this one. That's it. When you're done, can you help me put a thumbs up? That's my phone. Okay, good. Dylan done?
Almost.
Okay.
Wait, this lesson being recorded.
Yes, because some of them miss class, so I
Oh.
need to send them the recorded video. Done already? All right, Now, I will let you go first, okay? I want to test if you understand what I say in this lesson. So, okay, you can help me copy down this. I give you guys the worksheet for this, so you can do it whenever you're free. But I just want to go through one last question before you go. Can all of you turn to, where is it? Question 8. Okay, can you do question 8? When you're done, send it to me. and then you can go. Okay, question. Wait, I bring it to. Okay. Dylan, do this one, I can go. Hey Joshua, yours is good, but your presentation is weird. I help you change a bit. Okay. If not, yours is perfect. Okay, all is correct, just that your presentation a bit weird. Okay, then you won't get the mark. So just be careful. You must always copy the integral sign down and then slowly times. So always use the clue. Can you see? You must always copy the clue, then you work from the clue, and then you will get the answer. Okay, Joshua can go already.
Okay, bye, Joe.
Bye.
So what will we be doing like in half an
Later,
hour's time?
I will finish trigo revision. Okay, prepare the
Or you
trigger
mean
worksheet.
or you mean that's or that's the reason why you gave us the trigger worksheets, right?
Yeah.
Okay, can thanks.
See you. All right, Dylan, well done. Can go.
Okay, bye.
Fine. Tasha, everything okay? Sorry, you still doing?
Yeah, I'm still doing.
Okay. Okay, Tasha, well done. Okay, this worksheet, I just sent it to you. You can try, and then anything you're not sure, you let me know. Okay.
Okay, thank you.
Thank you. Bye-bye.